So welcome everyone to this talk named Some Things C++ Does Right. I hope you're in the right room and that's what you were planning to go for or go to. So my name is Patrice. As you can see, my email addresses are in the slide right now, which will be made available to you after the event, of course. If you've never been to my talks, or if you don't know me, well, I have a few kids. You will see some of them. Well, you will see all of them, in fact, in the slides that will come, because they're part of the presentation today. A number of animals. You will see a few of them, too, for some reasons. I used to write military flight simulators in the past and do R&D, but I've been a professor for over 20 years now, and this is pretty much what's bringing this talk to the fore today. And I'm also, incidentally, a WG21 member who hasn't been to the last 2-3 meetings because I've been very busy with the pandemic and such stuff. So let's start. You can see my beautiful wife here and one of the animals named Gracie. These things we do right, like my kids and animals and such things, things that are right in life, will be part of the presentation to give it some color, because the slides are white, to contrast with the black slides that I had yesterday. So you might have heard that C++ is not good for many reasons. Not memory safe enough, you'll see that. Not type safe enough, you'll hear people complain about this. It's a language where some defaults are wrong, or even, as some people say, all defaults are wrong. You can see that sometimes. I see that pass by. Whenever people tweet to me or write to me because they hate C++ and tell me you should use something else instead. Too expert-friendly. I hear that even from experts, which is true. Herb's talk later today will be about how we simplify C++. He's working on things. Many of us are. So yeah, people may be too expert-friendly, although my talk last year was about how you don't have to be expert to do C++. There's things about that. So there's truth. There's some kind of truth in there, because yes, C++ has warts, and it has to have warts. It has history. It covers a wide range of application domains, and lots of people work on it from the very low level to the very high level. It's high performance. It can do safety critical stuff. So yeah, it's when you go that wide, you're bound to have warts. But we do a number of things right. There's a significant number of things that we do right. And there's a number of reasons to love this language. I love this language. That's one of the reasons why I'm here, why you're there, I guess. We like it enough to get together, even virtually, to talk about it and try to understand it better. We enjoy coding in C++. There has to be something good about it. So this is a talk about the things that we do right. It's not exhaustive in any way, okay? Just as an example, I put this small tweet there that you can see right now when I was trying to promote my class that I gave last week, my CppCon class about managing memory. And I had this, memory management is one of the things some use to give C++ a bad name. And I was trying to put forward that you can do something cool with it. I had an immediate reaction by Jan, whom he was a very nice guy, who said, well, I thought it was one of the good things about C++ that we can manage memory and manage resources tightly. He said, well, yeah, some say that. I don't. I like it. I think we do the right thing. So it's not an exhaustive list. Far, far, far from it. We do a number of cool things, and we do a number of bad things, I know, but this is about the good stuff, some of the good stuff. There will be comparisons with other languages, so you will see some C# and Java code in there. Quite a bit of C# because I do more C# these days for school reasons. But it's not a C++ as good and the others are bad. It's more about the things that I like in C++ and then I miss when I'm not there. When I'm stuck doing something else, I miss C++ a lot. So, and I won't make anyone believe that C++ is perfect. It's not, but it's cool. It's beautiful. It's fun. It's efficient if you use it right. And I miss it when it's not around. So, as I said, C# is a fine language. Java is a fine language. JavaScript is a fine language. Python, Haskell, C, they're all cool. Okay? So this, I'm not bashing anyone, even though I'm going to take examples from other languages to make comparisons. They have good sides too. So let's talk about beauty and elegance. What you see there is Ludo. Ludo is now 7 years old. You'll see him later in the talk. He's my youngest son. I have 4 daughters and 1 son. So about beauty. When beauty is hard to describe when you're talking about programming languages, people will say, well, it's a bit cultural, maybe local, subjective. There's beauty in most programming languages, and C++ has beauty. So let's take this example for sense. So we have this game. I work with game programmers, as most of you know, I guess. And we have this class hierarchy in which we have objects stored in a pimple class. It's a design pattern, if you're looking for it, an idiom that you will find in Herb's books, among others. It's called monsters, the monster. So a monster is something you can copy around that has polymorphic behavior inside, whatever. And so you have this fight in your game where there's a carnage. So a monster said to another monster, well, you smell good today. And the other monster got angry because it's not supposed to say that, it's a monster, and they started fighting, and there's death all over the place. So after that, you want to remove the dead bodies and keep the ones that are left alive. If you're doing C# code, you could do something like this. So as I said, it's not a C# bashing thing, but still. So this is very easy. You look at this code, say, wait, cute, simple, nice. I have this list. List there is not a linked list. In C#, list is the name they give to what we call vector. So it's a dynamic array. It's fast when you add at the end. It's very slow when you remove at the beginning or something. So you do remove all. You pass a lambda. This is the lambda syntax of C#. It's simple, but it's less powerful than what we have in C++. It does less things. So remove all the not alive ones. Is alive there would be a property in that language. So it's simple. It's nice. Why? Cool. I like it. Yeah, but you're in C#, see? So that LST object there, it's not an object. It's a reference to a list. And you're sharing state. That thing shares state between the caller and the callee. So it's a mutable shared state, and you're affecting the code, the client code with this. So you have to think about your code. Was that the proper thing to do? It's something to think about. It's hard to reason on those things. If you're doing C++ code, it could look like this. So I have this remove if algorithm in there that Mr. Stepanov has given us, among other things, Stepanov and his team. And I actually like this. So remove doesn't remove anything. If you're not familiar with this, it moves it takes the things that you are not removing at the beginning, and it returns P in this case, which is the position, that's actually an iterator to the first one that you are not keeping. So from beginning to P, it's what you keep. So it's a good algorithm, does the job if you know what you're doing. You could, of course, use erase and other things like that. And then when I'm done, I keep the live ones. I'm using the sequence constructor in this case that takes a pair of iterators, a range, and creates a different vector from it. So supposing that my monsters copy well, this is actually pretty cute. And I'm working locally. So I'm working with my v passed by value. Maybe it's been moved into my function, which would be the right thing to do probably in this case. And I'm reasoning locally. So I'm avoiding the sharing state that we had in the C# code. I like this. I like this code. So if you compare both, the C++ code is a bit longer to write, but if you look at both, it is more general. It could apply to other things than just a vector. It's not tied to a specific member function. It's a general algorithm that works on iterators. And they generalize differently. See, the C# code is smaller, but it's specific. The C++ code is more general. It's a bit longer to write, but it's still 2 instructions. If you look at it, 2 instructions in both cases, a call to remove if and a return in our case. I like this. I like this because we can build from basic principles with it. We'll go back to that. There. The other interesting thing in this case is that, as I said, we're working on iterators. That's the genius of Alexander Stepanov. So we're not tied to vector. We could be using something else. There are rules, of course. Ben has discussed this in his talk earlier this week. But yeah, it has this nice upside. So one of the things that C++ does well is allow us to compose elegant and efficient solutions from basic sets of principles. I like this. It's not a case-by-case kind of language. It's not, at least not the standard library in the algorithms that we love to use. Let's take another solution. So you want to read all of the text from a text file, and you want to make a big string out of this. So C# has a simple function for that. It's called read all text. It's a static function of class file. Then there's no such thing as a read all text in the C++ standard library, of course, because that's not how we do things. So if you look at this C# code, The using static on the third line is to make the code fit on a slide. It allows me not to write console.write down there. So it's just read all text. And I'm reading the text from a file. I'm putting it on screen. So it's simple, but someone did this for us. Someone wrote this function. If you want to write it in C#, it's tricky. It's not very difficult, but it probably won't be the most beautiful piece of code you will have written in your life. The C++ equivalent of this, I think, looks like this. So you might see the read all text there, takes a file name, opens the file, and returns, well, a string made from the contents of the file using, again, a pair of iterators and creating something with the sequence constructor. So my read all text, well, it's a two-liner. It's cute, nice, and built from the same basic general principles as the return statement from the previous function. It's only missing includes. It's all there. So there's no special casing. It would work under, well, it works with the same principles as the previous case. I don't know if you like this. I personally like this. It's less flexible, of course, because it's a hard-coded literal, but you might think it's cool. You might think it's ugly. I've heard both. But if you look at the entire code, the whole code to get this result, it's a single function with a one-liner that delegates to the other function that we just wrote. So we can build extremely powerful and surprising abstractions from very simple, basic stuff, which I like. I think it's beautiful. I think it's elegant that we can do this. You might not want to do this, but that we can is actually pretty nice. Yeah, nothing more. There. So there's beauty about this. There's beauty, there's elegance. That doesn't mean frameworks that give you a whole set of functions on a case-by-case basis are bad. They allow people who don't want to get the basic principles to get along with their lives and do stuff simply. But still, still. Let's take another one. So you might have seen something like this if you went to David Senkel's talk yesterday, because he has essentially the same code under another name, because he was talking about monadic programming. It wasn't a monad though. So you want to apply a composition of function. You want to do f of g of x for some set of x's in a range. So replacing the two calls to transform at the top there, applying g and then applying f, to one that does the composition of both, to have only one traversal of your sequence instead of having two, to make it a bit simpler and a bit faster maybe. And this might have some other upsides. The RVO I'm mentioning is not tied to transforms for some other reason. And you look at this, and it's actually quite simple, with current C++, of course. So yeah, I like it. A function that takes two functions creates a lambda that will take anything and pass it to G, which will pass it to F and return the result. It's very simple, very cute. We can do that without much effort in C++. It used to be more complicated, but be careful, because this is what it used to look like with C++ 14 and before. It was a bit more painful before C++ 14. And I cheated on this one because I used auto as return type, which is C++ 14. But with 11, when you had to write all of the scaffolding, the return type was a pain. So yeah. In C#, it looks like what you see in the blue stuff down there. So it's not that much more complicated or that much more simple. The complexities are different a bit, I'd say, but you get all of the function signatures. So the way to read this is G takes a T and returns a U. F takes a U and returns an R. So you have a generic function f of g of x that will return a function that takes a T and returns an R. So T to U to R. The lambda in there is very simple though. The calling code is not beautiful in C#. You have to explicit the types when you call for something like this. It's not able to deduce everything because it's trying to check the contracts from the caller to the callee at call point, and it cannot do this in this case. It's not able to. Maybe someday, I don't know. So if you compare both, I wouldn't say that one is more complicated than the other. You have things to understand in both cases. When you call them both, well, which one is more beautiful? I don't know. But I do like the C++ version. The way it's expressed, it makes me more comfortable enough not to have to explicit the types there, because they can get pretty hairy in C++ sometimes, the types. Yeah. And of course, you can tell me, well, if you really want to do a good job, you have to forward the stuff in there, and then it gets more complicated to explain to people. Yeah, well, yeah. C++, it gives you control. It does. I like it. I don't think it's a wart. I think it's a feature. But yeah, it can be something you can take against the language or for it, but I like it. I like that we can control this, and we're not always taking everything by reference like in other languages, because that has other problems. So yeah, you want to apply a function in sequence to each argument of a function. This one is not for me. So you have a function that takes a function and a number of arguments and applies the function to each of the arguments. This wasn't from me, but it's so beautiful I had to mention it. It's from Sean Parent. So there's a number of syntactic elements in there, but look at this. It's on isocpp.org if you want to see it. It's from 2015. So there's this empty lambda there that takes anything. It's an ellipsis and does nothing with it. It's just there to make place for a call to something. And what will the arguments that lambda that is being created and destroyed, what will they be, these arguments? Well, what you see there. So it's a fold expression over operator comma, using f for each argument. And the comma 0 is to have a long set of integers, quite simply. And these integers are passed to the lambda that does nothing with it. This whole code actually fits in a tweet. So you might like, you might not like, but that we can express such complex ideas in such a generic way or general way makes me very happy. So now, is it beautiful? Is it clever? Is it both? You tell me. But I like that we can do it. Yeah, I don't have a C# example of this, because I don't think you can express that in C#. If I'm mistaken, write to me. I'm curious to know how it's done. But variadics in C#, well, I don't think it will do what you think it does. This is my son today. Well, today, recently, because the cat you see in his hands is a big cat now. One of the strengths of C++ is that it's value-based. I really like this. I took this tweet from Michael Case in August, who complained about reference semantic languages. I agree with him. So I like that C++ favors direct access over indirections. You can do pointers, you can do references in C++. We do that, but it's opt-in. It's not what we have by default. I think the fact that we have to make an effort and add syntax to get reference semantics is a good thing. I think we're doing this right, contrary to some other people. It influences the way we code, because we have objects, not references to objects in our code, at first at least. So yeah, some people will criticize initialization in C++, saying, oh, it's complicated, there's many ways. Because we have values, we have to take care of constructors. When we're writing string S, it's a string, it's a reference to a string. But other languages have their warts too. Check it out. This series of initializations, there are ways to initialize an int. So x0 has an unknown value. x1, 2 have 0. x3 is not initialization, it's a function. That's unfortunate, but that's the way it is. It's a function prototype. x4, 5, 6, 7, 8, 9, they're all ints of value 0. So there's many ways to do this, and people could complain about this, saying, why do we need so many initialization means? There might be others. Didn't think about it. With strings, it's similar, but slightly different. We still have the function on S3, and S0 is an empty string. When I wrote this with my integer I0 and didn't initialize it, I had an uninitialized thing. But the rest is mostly strings. Now there's a catch with S6, if you look at it, because S6, it's not a string. It's a reference to an array of chars, or if it decays, in this case, because there's auto, it's a const char star. So yeah, it's complicated, you see. Well, this is C#. You say, hey, it's simpler, because S0 is null, I guess, but it depends on the context. Because if you use S0 like this in a function, it's not initialized, and it's an error to use it. But if you use it in an object that you have to create with new, it will be null initialized, because that's the default value. So S1 is null. S2 is an empty string. It's not null. A string, well, it's default, but default in C#, because it's a reference type, it's not an empty string. New string parent doesn't compile. There's no such constructor in C# for string, but parent, quote, quote, parent, it's an empty string, and it's equivalent to S2 in this case. So there's less cases, but I wouldn't say it's easy to grasp at first, because there's corner cases and weird stuff to think about there. This is amusing, though. Look at it. If you think we have the defaults wrong, think about this. Here I have a null S in C#. I do s.length, which is a property that gives me the length of a string, like our size function, and goes boom, because it's null. If you look at this, you have a null, and you do plus equals with something, it works fine. So you can do null plus equal as a string. Now you have to know things. This is not trivial to me. I don't know if it's trivial to you. But what happens is that there's a rewrite. See, when you do plus equals, it doesn't really exist conceptually in C#. It rewrites your thing to S equals S plus yo. S is a string. Strings are immutable. And the operator, that's the way it behaves. When it's overloaded, it rewrites your code with the operator plus. It's very hard to do efficient code in that language. And because the operator plus, when it has a string and a null string, a null reference, well, its behavior is to give you the string that's non-null. Well, you have length too. So maybe it's self-evident to you, maybe it's not, but I don't think it's trivial. This one is more amusing. So you have a null, plus equals a null, gives you, of course, an empty string. And then you can call length and it works. That to me is icky. That feels bad to me. And teaching, seeing students do that and scratch their heads is a bit weird to me. But hey, to each language its own warts. So I think we have a saner model for initialization that people will credit for, even though it has warts and it's complicated, I know. Look at this. So I have this integral class that by default initializes the value data member with create value. And create value, I'll put something on screen right now just to show it we passed there. There's the default constructor down there that default initializes the thing in kind of a way. It calls create value. And there's the constructor that takes an int argument that initializes value with the int. Well, if you look at this code, I0 will call create value, but I1 will not. I think that's same. If you're passing an argument to the thing, you don't expect the default value to be applied. You expect the value you gave. Why do some wasteful initialization before you construct the thing? But that works because in C++ we have objects, that references to objects. It's a different world. Yeah. This is C# code. Again, I'm not C# bashing. I'm talking about differences in meaning. So it's similar if you look at it. Create value, prints something on screen, and returns the default int, which is 0. The property named value, it has only a get, so it's not modifiable once the object is constructed. And it's default initialized in a way to create value. So it's going to call create value for the initialization. My default constructor, the public integral that you see there with empty parents, it will call create value. But the integral that you see at the end, the one that takes an int argument, funny enough, if you look at the code, it will call create value and then replace it with the parameter, the argument. You will see 2 calls to create value. Now, in this case, it's very simple. It's returning an int with value 0. We could do away with the function. But the interesting thing here is that you will get the wasteful call. You don't have any choice. If you put it there, you got to get there for everyone, regardless of what happens afterwards. So we have values by default. We have to make an effort to get pointers and references. And our objects, they actually construct their data members because they can call their constructor. They're not references to things. By default, they're objects. This is bad C++ code because it's default constructing the name with the underscore at the end, and then replacing it with an assignment, which removes what was there and puts something else instead. So it's wasteful. This is better C++, but we can do that in C++ because we have objects, again, and we're constructing them at first. When you're using something like C# or Java, it's a different mindset. So you have references, your values will be 0 initialized when you do new, and this will give you essentially a null value when you're using pointers. So something like this, if you do a new person, well, your name will be set to null initially, even though you initialize it in the constructor systematically. So you paid for the zero initialization regardless of what you're going to be doing. That's how it works. On the other end, name equals name with a big N and a small n. It copies a pointer essentially because it's a reference-based thing. So you're not copying a string, you're copying a reference to a string. And strings are immutable, so that's fine. And if you do a generate name function that does some computation, and you, let's quote by mistake because you don't realize what's going on, call it on all name properties, well, your initialization in the constructor, well, it will always call generate name. Of course, this wouldn't make sense if there wasn't a default constructor somewhere else. But anyway, so the point is you're always paying for this. C++ doesn't do this. So I think there's a same model that we have. Another tricky thing that we get from value semantics is the fact that we can reason locally on code. It's much harder to do that with reference-based languages, particularly when you have mutable state, because non-mutable state, it's not really a problem, especially with generic code. So this is some kind of smallish collection in C#. So bag of T, it's holding a list of T in there. So get means it's only initialized at construction time, not after that. You can just read from it afterwards. But remember, list is a class, so like a vector, and you get a reference to it. So when you're calling the get to the thing, you're sharing state with the others. This is the C# way of doing a operator bracket overloading. It's called an indexer. That's okay. And the get, again, means that I can only read the values in the array. I cannot write to them. So it will return the nth element of contents. That's okay. And there's this constructor there that takes a list of T and makes sure that it has 5 elements and less because I want a small bag. And if it's too big, I'm throwing an exception. I could use a better type than just exception. That would be fine. There's so many bugs in this code. It looks simpler until you do something real with it. So this evil function, see, it creates a list of 5 elements, creates the bag with it. That's totally fine. It's all ints. And then it adds another element to the list, your local list in evil, which is now shared by bag, because that's reference semantics at their worst. So you just broke the invariant from the outside. You're an attacker because you're doing something like this. To defend itself against that, the bag would have had to create internally, manually speaking, a new list and copy the elements and hoping the elements are either what they call structs, value types, or that they're immutable. Otherwise, they're still fragile. This is another breaking thing. So I have this bag of that takes a list with 2 things, and there are 3 things in there, 2, 3, 5. But thing is a mutable object. You can know that if you look at thing at the top part, because there's a public val with a set, so it's mutable. So when I do bag at the end, at the bottom, bag square bracket 2 square bracket dot val, and I modify the thing, I mutate the element inside my bag of things. So if that wasn't something I was planning to allow, I'm in trouble. But that's what you get when you get reference semantics by default. We get the same thing in C++ when we play with references and pointers. It's just not the default that we get. So it's difficult to reason locally. It's like you have pointers everywhere. People say there's no pointers in Java and C#. That's false. There's nothing else. And concurrency is more complicated because of that. In modern C++, we tend to use reference semantics, but we're not forced to do it. With move semantics, among other things, we can get more value-based reasoning. It's easier in many ways. Even pointers are encouraged to have unique ownerships. We use unique pointers more than shared stuff in general. So this is the C++ kind of equivalent of the bag. But if you look at it, it's safer because my operator square bracket, it returns a copy of T. And my constructor makes a copy of the values of the vectors. So it's kind of the same code, but without the problems, and with actual encapsulation that lacked in C#. It's trickier to do correct generic code in C# than in C++. Yeah. Let's talk about free functions a bit. The kid that you see there is Veda. She's 13 now. She's in school right now. She's in high school. Beautiful kid. So that was a few years back, let's put it that way. If she knows that I put it there, I'm going to hear about it later on today. There was a vogue. I know when I was a student, there was a vogue saying everything should be in a class. If main is in a class, it's a better main or something. Yeah. So the problem in this case is the same with C# or Java. I'm not bashing C#. It's interesting. There's actually something cute about it. So let's take this beautiful code. Let's put it this way. There's this supermath class that has a static function named square that takes an int and returns the square of an int using system.math.pow. And main calls this thing and does supermath.square too. There's a lot of noise in the code. Yeah? And you can ask yourself, why are there classes in this case? Well, there's nothing related to class-based programming in there. It's just functions, But they're required originally, at least. But there's been efforts. So now they have static classes that you cannot instantiate and that can contain only static members. They're kind of closed namespaces of sorts. So you can put static there, and static still in your function, and you're still calling supermath.square. That's fine. That's a start. We haven't gained much from that. But now we can do using static with C#. So when you're doing using static, you're doing shortcuts for the member function, the static member functions of the static classes, but only these, such that you can avoid putting the name at front. So if you're doing using static supermaths, like you see there, look in main. You don't have to write supermath.square. You can just write square because you have using static. It's a shortcut. And you can continue. This is cool. If you use using static system.console, then in main you can just do write. You don't have to do console.write or system.console.write. Cool. And if you push it further, you can do using system.math. And then you can just write pow in supermath instead of writing system.math.pow or just math.pow. But look at this code. If we had functions, we'd be done. So all this work, some of this comes from C# 8 or 9 or something. All this code to get to functions. I like functions. Sometimes functions are what you need. Sometimes they're the right thing. So yes, it looks novel, but it's a lot of work to get to where we were 30 years ago. The guy, forget the guy at the back end who hasn't shaved that day, but the girl in front of you is Calypso. She's daughter number 2 over 4. Veda's daughter number 4, the one you saw earlier. And the dogs that you see there are still with us. If you hear dogs yelping, these are the ones. They're called Obi-Wan, the brown one. He's not very intelligent, but he's very sweet. And the Shih Tzu in front is Gracie. I really like const. I really like const correctness. Now, I talked about that in my other talk the other day. The fact that we can say something like this member function will leave the object unmodified when you call it, it's brilliant. But not everyone agrees with me. See, there's a big quote that I won't read for you. I'm going to tell you where it comes from, though. A big quote that explains why some other languages don't use const. I'm going to put a part of it like bigger. See? This part says, if you declare a method that takes a non-const block, you can't pass it a const block. So you're stuck. You gradually need a const version of everything that isn't a const. And you end up in a shadow world. So those of you who were with me yesterday, you might recognize something there. So there's something wrong there. Not again, see my other talk. But the guy who wrote that thing, he's not dumb at all. I mean, he's the guy who wrote C#. He wrote the Delphi and TypeScript. So he's a brilliant guy. This is actually taken from an interview in 2004. I understand the point of view. I know that there's other reasons why they don't have const in C#. They have const, but not in the sense that we intend it in C++. But he's not dumb. It makes sense in the mindset that he has. But there's something cool about this. And he's right in the fact that we need ways to circumvent const in some cases. So we have mutable, we have constcast. There's things like this that we need to be productive. We can opt out locally, but it still works. The fact that you can opt out of it doesn't mean it's bad. It works. Many languages go by without const. Java is final. So you can make references immutable, but not necessarily the referred objects. You can do set values on them if you get the final reference, but still it's useful. C# is read-only. It makes, again, references, not the referred to objects immutable, but it has something. And you can do const for some things too. but not everything. Some things. So const int makes sense, and it's always static. You cannot write static. You have it by default. So this is a bit of C# code. The integral class that you see there, the point of it is that the value is mutable. So you have get and set. People write code like this. I'm not bitching, by the way. If you look at toString with the arrow function, the arrow notation for things that just have a return, I kind of like that. I think with the operator dot in C++, we can get something that's cute like this. So this is actually nice. So you have an integral class that's mutable. Look at it. I have my point class there that has read-only integrals, x and y, and the properties, big X and big Y, lets you access, without modifying them, the data members. Let's put it that way, X and Y. The point constructor creates new integrals. So the point in this case, to make a bad pun, is to have an immutable point of sorts, which is not achieved. I can tell you this right now. The reason it's not achieved is that the X big X thing gives me access to the X small x thing, which is read-only, but that does not prevent setting the state of this thing. I just cannot change the reference for something else. So if you look at the code that you have right there, I'm making a point to 3. And when I do pt.x, that's an immutable reference, but the referred object is totally mutable, and value plus plus changes the value of the point. So it's difficult to do something like this, at least with classes. You can do it with structs sometimes, because C# makes a difference between classes and structs. So the real problem in this case is that it's lacking value semantics. If you're playing with classes, you lose value semantics. Yeah, you're playing with pointers. But a lot of people do code like that, and they don't think about it because they think they have objects in their mind, but in their hands. But you almost never have objects when you're playing with these languages. You have references to objects. Your mindset is reference-based. This C++ version of the thing is value-based. So my integral as an int, I don't have a set. It's by design. I want it to be immutable of sorts. I have operator, the operator to put it on an output stream to display it. Fair enough. I don't think there's any big difficulty. My point there is two integrals. My x and y accessors of sorts return copies of the integral. Okay, it's value-based. And I cannot modify my point the way it's written in this case. Of course, if I make an effort, now this is small, but the point is, if I want to put pointers in there, if I want to make the effort of making it, providing it with indirect semantics, and some people do that on purpose because they think there's a way to do object-oriented programming. Don't ask. Well, the constructor might leak. If you don't understand why, you can come and talk to me. I'll tell you why. I had to make it uncopyable. If you look at the mid-section of point, there's 2 equality there because I have to. If I make it copyable, I have to write a copy constructor to copy the referred to objects and everything. I put the const, but returning references x and y just to make a point in this case. Like the functions are const, but they're returning references to the pointers, so I can do dirty things with them. And I have to make a lot of syntactic effort to get reference semantics in C and C++ and pointer semantics, which is good. I mean, if you want to do something like this, it has to be painful. It's not fun. The natural code is value-based. And when I make all of this effort, well, I introduce problems like the one you see in the bold part, the boldface part of the code, it becomes mutable. So yeah, value-based by default is a very good idea. It lets you reason locally. If I use a unique pointer, it's still more complicated. And if I do auto ref in my x and y functions in the middle there, well, I'm still getting problems. I can't return a copy of these things, see, because they're unique pointers, so I have to return references. If I return const refs, that might be in better state. But if you look at this code, it's less fragile than the previous version, but still a lot of work. Value is easier in C++. And I can still do something like what you see in the boldface code, in this case, because I return references to my unique pointers. And when I'm modifying the contents in there, it's because I'm modifying the integral that I'm referring to, not the unique pointer itself. I could not call a non-const function of the unique pointer, but what's in there, if it's accessible by ref, I can replace it. So Nothing's stopping me. So yeah, value-based by default is good, because if I make efforts to point myself in trouble, it's nice that the simple code is the good code. So I love code. Const plays well with value semantics, and C++ is a value-based language. Tony Van Eerd has told me that a few times, and I agree with him, except that he gave this talk, and I disagree with the talk. So Tony had this good talk. He's a very good speaker. So this talk in 2019 with objects which shows values, putting in front that C++ is a value-based language. But and you can I invite you to watch the talk. It's always fun to watch Tony. And in this talk, he presents objects as reference types, kind of like C# and Java do, and distinct from values. But I disagree. That's my point. In C++, what you have by default are values. You make an effort to get out of it if you really want to. But still, go watch the talk. And he's got other good talks too. The question came yesterday. Matter talk, it comes often. Should const be opt-out instead of opt-in? Should it be the default? Well, we're in 2020, so we have hindsight. Maybe. It's possible. Rust does that. It might be a good thing. From the 1979 perspective, it's not as clear to me. But this does not prevent us from doing a good job with const. We can do a good job. It's useful. It's not perfect, but it's useful. This is Veda again. She's 13 now. The cat there is Minion. You should see the paws of that cat. It has like something like 10 toes per hand or per paw. It's one of our oldest residents in the shelter, and we kept him because it's just too cool. He sleeps in the sink in the kitchen because he wants water to be dripping instead of in a bowl. He's a huge cat. Friend is a controversial topic. I heard about it a few times this week, people saying, I don't get this. And some of you might not agree with my examples, but anyway, let's try this. So I read in books and I heard in classes given by other people that friend is bad, dangerous, and a breach of encapsulation, which I think is not true. Well used, at least it enforces the encapsulation. It adds something to the code. So you might, as I said, disagree with my example, but that's fine. So let's say we have a type that needs two-step initialization that exists. And that exists in real life, a thread that you create and then start afterwards for some reason. In some platforms, you want to get a resource like a window, and you have to call an init function on it afterwards. There were examples in the singleton code, one of the talks this morning, that required that too. But it wasn't explained why, though. So it's like this. It's a two-step init thing, a very good name that has a constructor that does not finish the job for some reason we don't know. And then an init function you want to call, and then use, of course. So the main that I have, the bottom part there, well, it creates a default two-step init thing, and then it calls init, and then uses as one should. But of course, as you know, programmers, they don't do as we should because they're programmers, so they have their own mindset. So if you leave it to programmers' discipline, you'll get what you deserve, see? They will do something like this. They will create and use and not call init, because programmers are like that. They don't listen. They don't read the comments. That's what they do. You know that. So you look at the literature from the ancients, and you say, oh, when you have a two-step thing, you could do a factory. So hey, design pattern in books is bound to be good. So you want to make sure that init follows construction, because that's what you plan to do. So you go there. You do a two-step init factory that creates inits and returns. Why not? Except that if you look at the code, the init and constructor are still public. So people could do it right, like you see there, and do what you asked. And people could do it wrong, of course, because people are bad. They don't listen. You give them tools and they don't listen. Anyway, it's part of life. So you could use friend, but if you don't want to use friends, you have options. So if you're in a language without friends, you have many options still. You can use an interface. The C# and Java way you will see normally. You have an interface, and you make sure that the class is only visible to the factory. So something like this. You have the usable interface with use. That's abstract. You have your two-step init factory that returns a unique pointer to a usable, because you don't want to expose the details. And then your source file, you make two-step init thing some kind of usable. So you deface your design a bit by adding polymorphic behavior and adding a base class and stuff. And your two-step init factory creates and initializes the two-step init thing and then returns it as a usable. So that works. Some people will consider that satisfying, but there's costs. You can also make two-step init factory a class and make your two-step init thing an inner class so that we don't see it from the outside. And then you still add the overhead of the interface. Something like this. So you make it inside. And then you put your code in this. You could make it you can make the factory function this code is bad because the function should have a different name from the class. There's a bug in that slide. Anyway, you can add a static member factory function to your thing too, like this. So you put your static function inside the two-step init thing. You push your constructor and init functions to be private, and you make it so people have to write two-step init thing, colon, and then it would require another name again. There's a bug in the slide, create, say or something. But all of these solutions, they have a cost. You have to allocate because you end up doing a new, using a unique pointer in some cases. You have indirect calls. You're restructuring your class to do something different than what was planned at first. It's a minor init, but it's a init still. You could also wrap your two-step init thing in another class and make a wrapper that in its constructor creates and initializes and then delegate from the outside to the inside the functions. There's a number of ways to solve this. Friend has the advantage of doing what you want, not more. So you can say, well, yes, init is private, the constructor is private. So if you want one, well, call the function that's my friend, and it will do the job. That's it. It has nice properties. So yeah, we can complain, but it's nice property. Works well. Java has something else. Java has package private. So if you don't write anything, that's what you have. It's not the same thing as private protected public. So it's not the same rules. The rules are there, in fact. You can look at them. So with public, everyone has access. Protected, it's you, your package, your subclasses. So package is the module in which you are, say. If you do nothing, it's yourself and the other classes in the same package. And if it's private, it's only you. So that's the Java way of doing things. So we don't have the package concept in C++ yet. With module, maybe we'll have something like that. C# has other things. It has internal, protected internal, private protected, different relations, but it not have friend. So internal is everyone else in the same DLL. It's what you have by default, for at least for your classes, not the internals. Protected internal means, well, your child classes, and the ones in the same assembly. And private protected, it's you and your child classes, but those in the same assembly, not the other ones in the world. So there's nothing that says only you in there. So if you want to point fingers and say it's you and nobody else, you cannot do it. So it's more precise, but you have to be careful because you can have many friends. So if you do something like this in C++, it works today. And so in this case, all of the aficionado of T are friends of the popular. That's a bit aggressive. You have to know what you're doing if you're doing something like this, because you see n there is private. And if I'm using my own aficionado that does a fetch from a popular and returns the n there, if I wanted this to be hidden, well, anyone can make an aficionado of void and fetch from it. So yeah. So if you do something like this, you open up a breach. You have to know what you're doing. But friend, by default, doesn't go that far. This is Amandine. It's child number 3 of 5 for the third daughter. There's upsides to iterators. I know that time is flying, so I'll try to go fast. Let's say you want to write your own reverse function. It's something you will see in Stepanov's book, C++ 17 style, and you're using the new ranges there. So it looks like this. See, it's a very simple algorithm. You have beginning, end, and while they don't cross one another, you pull the ending towards you. You compare them again in case something they're crossing one another. You're swapping the values, and something like this. Very simple. Look at this. It works with vector, works with list, works with deck, because it's a generic algorithm based on iterators. It's the same function adapting itself to what we pass it, as long as it's reverse iterators, not reverse, but bidirectional iterators that you have. So it's essentially independent of the container. It has expectations, but it's limited. If you want to do this with C#, and you want to do something general, you start. Say, okay, I have an enumerable, because that's the way it works. That has an interface for something that you can go through with for each. Say. And then you look at the documentation. Well, you say with an enumerable, I can get an enumerator. And from there, I can move next. I can look at the current value, and I can go back to the beginning, but there's no end. There's no end. So, well, you can model easily in infinite sequence, but writing reverse is a lot trickier than it looks. It requires additional state. Let's say you have to allocate and stuff. So it's difficult to write properly, at least. You can add functions. There's something called system.link that adds methods from the outside, extension methods, and there's case-by-case implementations and virtual calls in there. So you can do it, but it's a very different philosophy. So there's elegance to iterators. We can express general algorithms. I mean, many of us love this thing, and you're not imposing yourself additional calls for virtual functions and such. If you want to make a list of int from an int array in C#, well, it's evident. You call toArray.toList. There's a specific function to get a list from an array. It's written like this. And if you want to get a list from an array from that list, you call toArray. It's a case-by-case thing, and it works and is discoverable, and that's totally fine. It's a philosophy. If you use LinkQ, you are going to have other functions like this. There's a set. If you want to make a vector of int from an int array in C++, well, you call begin and end and use the range constructor like this. And if you want to make a list from the vector from the array, well, you do the same thing. It's general. It's general. You're not on the case-by-case thing, but you have to learn things at first, though. It's elegant. And you have to write only one per container, not one per type of thing you might want one day to go to or to convert to. That's kind of neat. I'll let you figure out what this is, but there's a few like that in my house from day to day. I really like variadics. These I really miss when I go to other languages. So we want to serialize a series of objects with standard output. We want to take objects and print them to a stream. I'll make it quick. This is Java code. You see the ... thing? We have that in C++ too, but there's a different meaning. So in Java, when you do ... it will synthesize an array at the call site. So you have to have objects of the same type. Now, if you look at the example call, the print at the bottom of the page, you see, well, I have an int, a double, a string, and an x. It will work because everything is an object in C and Java, and object has toString, which is called by print. So this thing makes me an array of object. So it's allocating an array. The size is determined by the call site. It's actually neat. It's cool. So you're paying for a few things there because int and double are not classes. So there's boxing, which creates class objects in there. But anyway, it works. C# is similar. The params thing there with the array, it creates an array at the call site, but it's an array. So objects have to be all of the same type. See? That's the way it works. So that's you get simplicity, but you pay for something. And again, objects in C# have toString, so you can call toString on them with the for each thing. Same principle. C++ version might be harder to understand. I know this one is not the perfect version. It's simple. But it takes any number of arguments of any type and doesn't create an array, it just prints them. It's naive, but it's still cute. No conversion to string, no synthesizing an array, simple. It's harder to write, I know. When I show this to people who are not used to C++, they wince. But the point is, it's very easy to use, though. That's the good thing, and there's no real cost. And with full expressions, it's even cooler, but that has to be explained to those who aren't used to it, but it's pretty nice. So I like it. I like the way that we can express things like this without incurring the costs. Yeah, of course. So they're part, to me at least, of what makes the language beautiful. It's not an obvious syntax. You have to get used to it, but it makes you expressive. This function is totally useless. It's my last one in the talk. It's totally useless, but it's fun because it shows what you can do. Things you can do, not everything, of course. So it's a function that takes any number of integers as template parameters. I could put auto instead of int, but int is what I want. You can make an array of the proper size. So this is a compile time size because the number of ints is known when I compile my code. So that's totally fine. I can initialize the array with the values. Could make it const expr if I felt like it. I don't even need to put the size of dot anymore because the values are in a compile time known number. Anyway, I can, of course, iterate through the array and print stuff. This is why my function is not const expr, because I'm printing. So that's OK. Or I can just iterate on an initializer list made of the values. And that works too, because initializer lists have begin and end. It's general. And if I want to return the sum of the values, well, I compute the sum of the value. If I remove the counts from there, it's the const expr function. The fact that we can express these things in C++ so simply makes me so happy. And when I move to other languages, I miss them so much. So a few words about fun and we're done. The tall girl at the left hand is Marguerite. It's child number 1. And the other two are in order, child number 4 and 5. I like programming. I really like programming. I miss programming when I'm not doing it. I'm grading papers a lot these days and programming a lot less. The problem solving, the action, the act of doing this, I love it. I love building solutions from principles. I love using and writing algorithms. I love conceiving containers. I like doing that. I'm not against libraries. Don't worry about it. But I love it. I love it. It's an action that I appreciate. I like that at the top part, there's a specialized thing. At the bottom part, there's a generalized thing. With all lines, same thing. It's not much more difficult. It's exactly the same thing, though. I would have to make it a bit different, but it's a similar idea. I like that when I want to make list to array to list up there, there's a specialized function. At the bottom, there's something general. I like that if I want to convert to any container, I can still do it with the same syntax in C++. And it's not something that makes sense in some other languages. So there's something to learn, but there's a reward. And that reward is, in part, fun. There we go. I hope you enjoyed. I'm there for you. If you have any questions, there's an AMA after the talk if you want to have a chat with me. And if you want to complain or speak, I'm there for you. I'm there right now. So a question will come in a few seconds. Without incurring costs from the template variables, do you not incur code size costs due to the specialization relative to generic box versions? Okay, now generic box versions, you're talking about Java or C# in this case, because there's no such thing in C++ as boxing for the code that I wrote. So the boxing costs something. It does cost something. The generic code in C# and Java costs a bit more than people think. For C#, it's reified generics. For some cases, it's not as costly as it looks, but you do pay for something, especially because you're going through interfaces and you're calling virtual functions. In C++, what you will tend to have is the code will be generated and inlined. So the costs you should measure, of course. But if you stick to small functions, you'll be surprised probably by the quality of the code that you get, especially when you enter const expr in the equation. So before throwing it away, consider that you would have written the same code by hand, probably, and that you're getting it for free now. And look at the code before and after. It's surprising. War story. In my PhD, I had this function that concatenated a number of strings. So it was a variadic number of strings. And I was going through the strings by one, getting the size of each, computing the length that I needed, creating a single string from it and everything. So it was clean code, good code. I replaced it by strs plus ... and it actually went faster. And I felt happy and sad at the same time because I had wasted so much time instead of testing the simple hypothesis that my compiler does a very good job. Yeah. This question is there specific things on write in other languages that you'd like to see in C++? Absolutely. Okay. One of the things that I like in C#, because I've been using C# a lot, so let's use that in the other sense. I like the arrow notation for small functions. I think it's a great idea. It's not as is a perfect fit for the grammar that we have in C++, but the idea is nice. What I'm thinking here is when you have wrapper classes, say, that delegate to something internal, you write a lot of boilerplate code that could be made simpler by the equivalent of saying my begin function is the same thing as that begin function. The fact that the properties in C#, you can associate a get with a computation and say, well, the surface of that square is equivalent to this computation based on the length and of one side or something. That's actually pretty neat. It's not just a matter of finding the right syntax. It's not essential, but it does make programming much more pleasant. So I like that a lot. There's things I like less in those syntaxes, but this you can get used to pretty easily. It's pretty nice. Yeah, that's just an example. There's a number of nice things. They have good libraries. You have to be honest. If you want to do HTTP operations in C# and Java, it's built in. In C++, we have to go outside of the standard to get something, but that's fine. It's okay with C++, but still, it's easier to wrap up a web service in those languages. Everything's already there. You don't have to look for it. Okay, this is an interesting question. Which engines do you use for game development? I don't make games. What I do is I teach those who make games. So I give classes to Ubisoft, Eidos, Square Enix, Epic, and a number of others. So they use Unreal, or they use Unity, or they use the Far Cry engine, or whatever they use. They come to me for programming techniques. They come to me for an upgrade in C++. And I take examples when I speak with them from the game world, but they're simplified examples because they're facing the big problems that are complicated, and I work with simplified versions to help them around. If I go to the very detailed problems that they get, we'll stumble on the details all the time, so we have to abstract things a bit. So I don't develop games, I work with the game developers. But that's what I've been doing for like 16 years now. When I did flight simulators, we had our own engine. I like const, but since I said I like it, is there a question behind that? How do you feel about const? I thought I was clear, but unless someone is joking with me. I like const expr a lot. I like const init a lot. I like const eval a lot. And const works wonders. If anyone doubts the strength of const, go back a few years in CppCon and look at Jason Turner's talk, where he uses const at some point to make the code melt. He's live coding a game on C++ 17, I think, that will run on Commodore 64 or something like that. And he does wonders with it. Const is magic sometimes. Okay, so we are in an AMA, and I didn't know we were in an AMA. Farbod, should I go to the room right now and show my face to people? No, I stay where I am? Okay. So yeah, it's an AMA, so you can ask any question you feel like. Cool. So anything is open. You cannot ask my daughters for a date, but apart from that, that's okay. Java doesn't have it. Do you mean const? Okay, so Java is final. So if you have a final int, it won't change value once it's been initialized. It has final for references. What you're missing is the const version of the functions. There's no. You can write immutable classes, but you cannot have immutable on the function basis and guarantee it from the signature. That's what you cannot do. It does work overall, but it has limitations. And as I said, C# has a number of features. C#9 has init for properties, which means you can only write to them when you initialize them, and that's it. But that's very recent. It has read-only. but that's for member variables. And if they're of reference type, well, the reference is read-only, but not the referred to thing. The point I was making is that when you have reference semantics by default, reasoning is complicated. Even with const, you'd be in trouble. So unless you had const member functions, but that doesn't mesh well with non-value type languages. It feels weird that const allows read-only parameters, but the only write-only parameter we have is a return value. Yeah, oh, well, the question that is there right now, although out parameters are frowned upon, if you're wondering about in, out, and in-out arguments, you should look at Herb's talk in 25 minutes. It's part of what he will be discussing. I know that not because he told me, because he gave that talk in earlier this year, and I know it's an upgrade of the previous talk, but it's part of the discussion he will be bringing. So I'm not 100% against what he's going to say, and not 100% for, but I think it's interesting, and it's something we should explore to see if it brings in what he thinks it will bring. So if you're wondering about in, out, and in-out arguments, go to Herb's talk in 25 minutes. Since we now have the rule of 0 leading to aggregates, well, it can lead to aggregates if that's what you need. Is that another reason to be sick over mechanical special functions that break that in odd ways? I'm not sure I understand the question, but please give me some detail and I'll try to give a proper answer. Exceptions and... for the question that just came in, what's your opinion on exceptions and herbceptions coming in C++20? Herbceptions are not coming in C++20, maybe in 23, if work continues to advance. We're exploring the thing. I think it's interesting. The people writing kernel code cannot use exceptions right now for a number of reasons. They could use probably these. If you went to Inbal Levy's talk just before mine, she was discussing avenues to replace exceptions for embedded, and these were part of the things she was looking at. She did some measurements. It was interesting. If my opinion on exceptions, myself, I use them. They're fine, but they're fine for me. I use them even on some embedded systems, and they work fine for me. But I use empty classes to represent my exception types. They're very slim. I don't use them much, but I use them. If you have constructors and you look for a way to signal failure to construct properly, well, the only alternative that you have is terminate or something such. Otherwise, you end up with objects that are in a bad state, and you have to use if statements and validate the invariance from the outside afterwards. So that leads to very messy code. I don't think it's that difficult to use. So just for the previous question, if you want to know more about exceptions, look at Herb's books, Exceptional C++. There's interesting things to think about in there. The costs, I'm going to finish on exceptions because I gave a few talks on that in the past that you can look at if you look on the internet. The exceptions have costs. The cost is typically not as big as people think, but they have a cost. There's an overhead in terms of size. There's an overhead in terms of speed. The size is probably unavoidable, but it's not as big as people think. The measurements that I saw here today do not conform to what I have measured in the past, but it's difficult to measure these things in real code. David Stone has done a bigger experiment than I have. David Stone is a guy who works for Uber, I think, self-driving cars. He's tried exceptions on bigger programs, and he told me that in some cases with I/O in particular, he got better results in terms of speed than non-exception based code. So you have to be careful with exceptions. There's costs, but there's upsides too. The biggest upside is that it makes it easier, again, to reason on code. Those who don't like them, they don't like the costs, and sometimes they don't like the hidden exit path to functions. But the alternatives are messy. So if I go to the bottom now to my list, I see how do you feel about teaching students new C++ features, such as C++20 features, when they do not have a lot of programming experience. When I work with beginner students, I don't do anything complicated at all. I use vectors instead of arrays. I do console-based I/O. I make simple algorithms that you could write in other languages. I gave a talk last year called C++ is the first programming language, really, because I did comparison with Python, Java, C#, C++ of the kind of things that I did with beginners. It's not that different. What C++ gives you is a bigger toolbox when you move outside of those basics. But I think, for example, that once you enter generic code, there's no big pain to using concepts right away. I mean, concepts are fine. They give you better diagnostics. They make your code clearer. So use concepts by all means. Vector is very easy to use for beginners. I mean, people can use list in C#. They can definitely use vector in C++. It's not more difficult. So the problem that I think we get often with people trying to teach beginners in C++ is they go to either C code, which is not idiomatic at all for C++, or they try to show that they're very good and use complicated things. No, not for beginners. Don't do that. When they start asking interesting questions that require complicated stuff, by all means, show them. But you don't have to start with that. I mean, algorithmic stuff that we do with beginners to get the ball rolling, understand how loops work, how functions work, you don't even need to use new in the first class probably, and it still works pretty fine. The question that I see now is, how did you get started with your teaching career? That's a funny one. So I was at CAE Electronics, which is a very important flight simulator company that we have here in Montreal. I was working on very, very big simulators back then, and I loved my job, and I still love what they do. I have a lot of respect for my colleagues there. I had let my resume lie around at the college where I used to go when I was a student, in case someday someone might be interested. And they called me when I was at CAE and said, well, we have an opening. Are you interested? So I talked to my then wife, because I'm remarried, and we looked at what it would involve. I said, well, let's try it. I plan to do that later in my life. And yeah, at the occasion, they hired me. Now, when I got my first paycheck, I said, what did I do? Because it was less than a third of what I used to make. And I had a family with 2 kids. So we had to adapt, let's put it that way. So it was a surprise to see the first paycheck. After 2 years of teaching in college, someone has contacted me from the university where I used to go, because they knew that I had an interest in that thing. And they asked me to come and start preparing material for a master's degree that they were preparing. My home base was Sherbrooke, which is a city about an hour and a half away from Montreal. And they were planning to open a campus closer to Montreal for the people living on the South Shore. So they were to be master's degree students, and they wanted client-server systems, distributed systems, and object-oriented programming, let's say. So I started writing very significant amounts of course material, like thousands of pages, and said, well, why don't you come and give the classes? So I did. So I've been doing that for 20 years. So now this is my situation. I give courses in both places. Can I recommend some reference material I'm using in teaching? I'm a bit of a maniac. Okay? So I write a lot of my own stuff. I have a very big website, but it's in French, with a lot of weird colors, because I don't see colors all that well. When I use books, especially for the video game programmers that I work with, because sometimes they need more than that. I've used Herb's books. I've used Nikolai Josutis's books. They're very good. I've used Scott Meyer's books that are very good too, but they're not all adapted to today's C++ because he's retired. So if I was doing something today, in the current state of things, I would probably direct you to Nikolai Josutis's books. You could also try, but it's not for beginners. Archer O'Dwyer has a nice book on the STL. It's pretty nice, but it's fun for those who already know C++ a bit and want to get a bit deeper. But Herb has gotchas. Herb has an interesting technique. He poses problems, doesn't always give all the information to solve them, and then he explores the thing. And he has levels like junior, intermediate, and guru. And you can get in trouble with any of these. Today, the fun thing that we have is CppCon. So you can actually look at some of the talks in CppCon if you're teaching students, and some of them, the Back to Basics track this year, you'll get some interesting content, I think, for your students. When you want to have fun, Tony Van Eerd has this amazing talk from a few years back called Postmodern C++. It's not a coding thing, but it's a coding thing at the same time. It's very good. James McNellis has an interesting lightning talk on his favorite C++ feature, which I highly recommend. It's a lot of fun. It's very funny. So we have, and these are just two examples among many. If you like algorithms, the most famous talk probably is Sean Parent's 2013 talk on C++ seasoning, the one where he talks about rotate. Everyone talks about it still today. Dave Abrams had a very nice algorithms talk in Swift. I think it's 2 years ago. So if you look at Dave Abrams' algorithms, you'll see it's a very, very interesting talk using Swift, but it's the mindset that's important. So I highly recommend that too. How has game development teaching evolved over all that time? That's interesting. Game development teaching, it's a complicated subject matter because there's many facets to it. So here in Montreal, we have a very big community of game developers. There's one university that is interested in the way the narratives are written. So how do you write stories? So they do that. So they're working with the game designers, I'd say. There are some colleges that work with sound, with gameplay, with the way the levels are being made. This is not what I do. We get the programmers. So how has it evolved? I started this year. I'm working with my 16th group for 16 years. We have a lot of international students, but it's in French. So if you want to come and study with us, you have to be able to understand French. The code is code, but the classes are in French. And how has it changed? Well, C++ has evolved, and the classes have evolved with it, the classes that I give. So I used to show how to write type traits. Now I show how to use the standard ones, and I still show a bit of how we used to do things before to give them an idea as to how much type traits with conditional and is convertible have brought to us in terms of simplicity. I myself, I've evolved. I don't write the same code I used to. I don't teach things the same way I used to. I used to take numeric limits as an example when I started talking about traits. I still show it, but it's not my basic example because it doesn't reflect current practice, which is to have smaller traits that do a single thing. Move semantics has changed a lot. I use move semantics a lot in my classes now. It didn't exist when I started teaching. It was 20 years ago. Move semantics are a C++11 feature. Another thing that I do is I try to look at what other languages do. There's good ideas everywhere. I do some Haskell from time to time, some Java, some C#, some Python, JavaScript. There's good ideas there. And these things, you put them together, you think. It's pretty good. So, but I don't do game development again. So I don't do anything specifically game related. I do a lot of hardcore C++ for game developers. I show them exceptions, even though I know they're not going to use it in their job, because it makes you think about safety. And maybe someday they will use it, I don't know. But today, most game companies, they don't use it. But still, it's good to know. No? So that would be my answer. I can give you a cute one. With the 5th group, so 11 years ago, I had a question one morning that came to me. I was thinking about it, taking the bus to work. And then I arrived there and I wrote a bit of generic code. It worked, it was cool. And I gave my class on that and we discussed it and we had fun. 2 years ago, 2 years after that, I realized there was a standard way of doing this, and it's exactly the code I wrote. So sometimes there's a mindset, you just fall into it, and you evolve with the language, and everything falls into place and is natural. It's part of the game. The biggest asset to teaching C++ these days, because it lets you use algorithms more easily, it's lambdas. Because you show lambdas, they start using this, and they have less of an incentive to use for loops. They can write more explicit code. How do we feel about Java checked exceptions? What a bad idea, isn't it? I used to think it was good, but if you think about it, it's a bad idea. It looked good. We tried that in C++ in a way. We removed it with the throw clauses, but it was a mistake because let's say you write your class today. You're in Java. And you say throws IO exception on one of the methods. And remember, Java member functions that are non-static, non-constructors, they're virtual by default. So you have this thing there that says, I'm going to throw IO exception if there's something that goes wrong. 10 years later, Someone does database access with a child class of this. They cannot report the actual problem that they face if they have a security exception or a networking exception or what have you, because the base class said IO exception. So they have to mask the actual problem to make the code work. So yes, it looks like a good idea. I'm going to say what I do, so code will be more robust, but that's not how it goes. You just bound your child classes till the end of time to an insufficient interface because nobody can see in the future that far. So there's something wrong. That part C# did better. It happens. What aspects of programming do you feel that game programmers often overlook or misunderstand? Okay, I think game programmers should know their algorithms. Some do, some don't. It's often a company culture kind of thing. There's some Unreal, for example, they make using algorithms difficult. They have their own dialect and their own classes, and they're not always an upside to the standard stuff. Sometimes they do, sometimes they are, sometimes they aren't. Algorithms are very powerful. You can say, I won't use the containers because they don't do what I want. Okay, but algorithms, there's no real reason not to use them. Containers, I think, are misunderstood because most of the time, if you looked at the code base of the game companies I work with, which are good stuff, they're very good programmers. They wrote their own containers 10 years ago or 15 years ago sometimes because the implementations they had of Vector and others, they were not up to par. Now, well, Vector evolves, we have move semantics, we have like new signatures to replace back and what have you. Their code doesn't necessarily evolve at the same pace because they have other things to worry about. So they don't gain the benefits of the upgrades of the language as quickly as they would like to, I think, because of that. Often the problem that they have is that they're not using allocators. They don't know how they work, and they could benefit from that. Now I'm building with the game companies these days a list of things that they need from the language. I'm going to bring that to the G14 soon. I have a meeting next week about that. So maybe you will have a better list of what they need if you want to know what they desire from the language pretty soon in the meeting, if you look at it. How do I pay? So the question is, how much attention do you pay in teaching to clean code design with respect to just solving an assignment? I read the code in most cases, so I give very detailed feedback. It takes me forever to do because I just looking at the execution doesn't tell you if the student has learned anything. Anyone can make code work. It's not meaningful if you want to get skills. So no, I read the code. So I pay for it. I pay for it dearly in time and effort. And that's why I get examples like the ones I had in my talk yesterday that are sometimes evil. I pay a lot of attention to that. In fact, I care about the results less than about the code, which might be a failure. I don't know. I was told that this was the last question. So write to me if there's anything. By all means, feel free. I'll be glad to speak with you. Thank you, Farbod, for helping me. You're an amazing volunteer. Thanks, everyone.